Okay, so I want to look at some more examples on implicit differentiation. And so, again, just kind of recapping or just reminding you some things. Remember that the variable that's in here, the denominator, that's your independent variable. And so you can take its derivative for free, right, without having to worry about anything else. But it's the variable that you see on top here. Oops, sorry. Remember, that's your dependent variable. That's the one that there could be a function y in terms of x. So it needs the chain rule. You do the derivative of y, but then immediately afterwards, you have to hit it with the chain rule, dy dx, whatever the derivative of the inner function is. And remember, we don't really know what that inner function is. So we have to hold a place, so to speak, structurally for that derivative. Okay, so it says find dy dx for this equation. So again, just think, okay, like 2y squared, the derivative would be 4y to the first power, but then immediately afterward, we multiply by dy dx equals, and then the derivative of 8x cubed, remember x is our free variable, so that's just 24x squared, that's our independent variable, minus, and then a sneaky chain rule. Be careful, or not chain, I'm sorry, sneaky product rule, because it's 6x times y. So, I might want to think about, okay, well, so minus, okay, the derivative of 6x is 6, leave the y alone, plus leave 6x alone, and then you multiply by the derivative of y, which is 1 dy dx. Okay, so there's your product rule. So I have 4y dy dx equals 24x squared, and then I'll distribute this minus 6y minus 6x dy dx. Okay. And again, remember, like when you do derivative of x and you're not doing anything with the derivative of y, then you don't need the dy dx, right? You only need dy dx when you're taking the derivative of a variable expression that has y. Now, here are two terms that have dy dx. I want to put them together. So I'm thinking what I'm going to do is I'm going to take this term here and add it to the left. And then that way I've grouped the things that have dy dx together. All right, so go back to that. I guess it's darker green. So I have 4y dy dx plus 6x dy dx equals, then we'll leave our 24x squared alone and our minus 6y alone. Okay, now let's factor out that dy dx. So you're going to pull out that dy dx, and we get 4y plus 6x, and then equals 24x squared minus 6y. And then finally, we can divide by this quantity. So dy dx is equal to 24x squared minus 6y divided by 4y plus 6x. So there's our derivative expression. Okay, very good. And again, that was a sneaky little product rule that I had remembered to take the derivative of, 6x times y, to separate that into two separate entities. Okay. Now, here's another, I guess, more simple equation, but I'm asking a more complicated task, right? Find the second derivative. Well, to find the second derivative, you have to find the first derivative first. So let's do it. Y squared, its derivative is 2y, but immediately multiply by dy dx. And then minus 8x equals 0, right? Constant. So still solve for dy dx, right? Still get that dy dx by itself. So I have 2y times dy dx equals 8x. And let's divide the 2y across. So dy dx is equal to 8x divided by 2y, which is equal to, divided by 2, 4x over y. So here's what dy dx is. That's the first derivative, okay? Now it's asking for the second. To find the second derivative, you do the derivative of the derivative, right? So to find the second derivative to find the second derivative of y with respect to x, twice, we do the derivative of this. Now, I'm not there to hear the moans and groans, but yes, that's a quotient rule, right? Low d high minus high d low over low low. So here we go, quotient rule. Low d high. So the low is the y, d high is just a 4 because the derivative of 4x is 4 minus high 4x d low. Well, what's the derivative of y? Well, it's 1, but then you must immediately multiply by dy dx divided by low low, y squared. So that's not terrible. It's not too bad. So that's equal to 4y minus 4x dy dx over y squared. And so you might be thinking, great, that's it, I'm done. I'll be saying, no, it's not great. You're not done because our expression cannot have a dy dx in it. So we were looking for the second derivative, right, which is what we're solving for, but it has a dy dx in it. We have to get rid of this. But here's the thing. You already know what dy dx is. You just calculated it. It's right here. So what we need to do is sub in that particular expression. Oops, there we go. Sub in that expression right there. Okay, so we have a little bit more of algebra to do. The calculus is done. And I always say this every year. Calculus is easy. It's the algebra that's going to get us a mistake because there's so many places where we can make that mistake, unfortunately. Okay, so let's do our best to be careful to avoid those. 4y minus 4x. And then we input 4x over y. And then we divide by y squared. Okay, so again, I'm writing very big and taking up lots of space. Hopefully you're efficiently writing this example. That's minus 16x squared divided by y squared. Now, I want to simplify this a little bit more. I don't like the fact that there's a y sitting here. So what I'm going to do is I'm going to simplify this complex fraction. I'm going to multiply the top by a y and the bottom by a y. So like really just a fancy 1, like y over y, because it'll get rid of this denominator's y, but I have to distribute to there and distribute to there. So now, oops, I'm sorry. Go to my color here. So now I have 4y squared minus 16x squared divided by y cubed. And that's a pretty simplified answer. That's a pretty good answer. Okay. But here's the crazy thing. It's not really the most simplified answer. Okay. And here's why. Factor out a 4 for me. Come over here. Factor a 4 out of the numerator for me. So 4. Oh, thought I went to a different color. That's okay. So I have y squared minus 4x squared over y cubed. And here's the thing. It's a really cool little trick because you know exactly what y squared minus 4x squared is, right? And if you don't know, look at the starting problem, right? I just had this Hamilton song. If you don't know, now you know. I know that Jefferson says that in one of the songs in Hamilton. Okay, sorry. Anyway, my brain is crazy right today. Okay, look at, right? Y squared minus 4x squared. What does it equal? 6. So that's kind of a cool little trick that you can solve that, 4 times 6 over y cubed. So you get 24 over y cubed. That represents our second derivative. So very cool. Now, let's say you don't see it and you left it like this. That's fine. But it's a sneaky little trick that the AP exam has done where they've made this a multiple choice question and they make you choose this. Like you have to somehow come up with that equivalency. So just be on the lookout for that substitution. Okay, stop the video and again, go back, take a look and see what kind of questions you might have. And then we'll just move forward. Oops. And